Root 3 plus 2 times root 3 minus 2. Now, root 3 plus 2 and root 3 minus 2 are called conjugates of each other. So what a conjugate is anytime you have two terms, so it's something plus something or something minus something, will make two terms. Anytime if you just change the sign from minus to plus, as long as the two terms are the same. So 2 plus 1 versus 2 minus 1, 7 plus 3, 7 minus 3, 11 plus 1, 11 minus 1. They're all called conjugates just by changing that sign. And what our point of this first couple examples are is I just want to see what happens when we multiply conjugates. So we're looking for patterns here. All right, let's do this. So I'm going to start with root 3 times root 3, which I know is just 3, but I'm going to write this as root 9. Root 3 times negative 2 is minus 2 root 3. Positive 2 times root 3 is plus 2 root 3. Positive 2 times negative 2 is minus 4 on the end. I'll just change that 9 to a 3, but then this is the part of what always happens with conjugates, is that these two middle terms you're going to find, we're going to do another example, the two middle terms always cancel each other out. So the negative 2 root 3 plus 2 root 3 disappear. And then what we're left with is root 9 is 3 minus 4. The roots will always disappear because they're the same no matter what. And we end up with a number on the bottom, negative 1, which is rational. So what the point is of this rationalizing is that this is how we can rationalize a denominator that has more than one term in it. All right, so let's do the second example of multiplying conjugates. 3 root 2 times 3 root 2 is just 9 times 2, because the root 2 times root 2 is just 2. 3 root 2 times 2 root 5 is 6 root 10. Negative 2 root 5 times 3 root 2 is negative 6 root 10. And then negative 2 root 5 times 2 root 5 is minus 2 times 2 is 4. Root 5 times root 5 is just 5. Again, in the middle, the 6 root 10 and the negative 6 root 10 cancel. So this is what always happens with conjugates, is that these two middle terms. So what a lot of people think is normally they think, okay, when I got to multiply these, I'm going to do FOIL, first, outside, inside, last. Well, when they're conjugates, if you recognize the pattern, you can skip the outside and the inside. You can just FOIL it, FL. So you can just multiply firsts and lasts. I'm not going to do this in any of the examples. I'm always going to FOIL things, but just know if they are conjugates, it is a shortcut. Okay, now finishing this off, 9 times 2 is 18, minus 4 times 5 is 20, and 18 minus 20 is negative 2. So again, we got another rational number. There's no root in this. So again, this is how we can rationalize the denominator. So a product of conjugates is always going to be rational when dealing with square roots.